Hello, everyone, and welcome to today's SANS webcast, Passive Isn't Good Enough, Moving into Active EDR, sponsored by SentinelOne. My name is Debbie Gruey with the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are Justin Henderson, SANS expert, certified instructor, and course author, and Migo Kedem, Senior Director of Products and Marketing at SentinelOne. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Justin.
Thank you. So, okay, everybody. Hopefully you're joining this because you're in the massive ensuing of endpoint monitoring, prevention, detection, response, and you're hoping to gather more information. In this webcast, this webinar, we're dealing with the differences between passive and active EDR. And it's this concept of EDR in its infancy gave us a lot of monitoring capabilities. But then when we deployed it, we introduced ourselves into a whole nother world of pain points, solving some but generating new, and that's why Active EDR came into existence. So today, it's going to be myself, Justin Henderson. I'm going to be representing SANS as an independent security researcher, and then we're also going to be having join at the later part of this presentation, Migo, talking about SentinelOne and Active EDR. I love these kind of projects because I'm given the opportunity to dive into existing technologies, newer technologies, yet still stay independent and neutral. So I'm going to be representing this as much as I can from a non-biased perspective, and that's great because we're going straight into the truth of matters and how to improve your overall security posture. What we're trying to cover is endpoint monitoring, really. You've got thousands of them, hundreds of thousands of them, potentially even a million, depending on your size. They're inside your organization, they're outside your organization, and they're moving all around the place. The problem with this is configuration management, all that, and keeping the monitoring up to par, it gets to be really challenging. So I'm going to start off by covering kind of what do we have with endpoint monitoring today, because we actually have tremendous visibility. As the SANS author for 555 SIM detection, 455 SIM design implementation, and defensible security architecture, I'm a big fan of living off the land, using your endpoints as much as you can. So I'm going to show that there's a whole bunch of things we can be doing with this. But at the end of the day, if you're just living off the land, well, you already know the answer. It's so much information, so much tuning, so much change management. That's a nightmare. So we're going to go into the pain points behind those solutions. Where there's gaps in visibility, there's gaps in prevention. And from there, we're going to roll straight into EDR. Now, EDR, Endpoint Detect Response, is an evolving technology, but it hasn't evolved as fast as it needs to. But there's starting to be this big shift in what I think EDR was always intended to be, which is fully helping find the adversaries in your environment, the unauthorized actions taking place, but actually presenting it in a way that you can actually utilize. So I'm going to start off by going into what is EDR, roll that into the new evolution, which is Active EDR, and kind of point out what you need to look into to make sure you're picking the right EDR solution if you're going down that route. Obviously, if you don't know why you would go down that route, we're also going to cover that. So let's start off with endpoint monitoring. We've come from the days of intrusion detection systems. We have technologies like Zeek, Corelight, all these awesome network security monitors. And I grew up in those days. Some of you have probably heard the phrase, PCAP or it didn't happen. But the truth is, those are great, but so much is occurring within the endpoints themselves. You have attacks like fileless malware, like memory resident or PowerShell, or just anything that lives off the land that is occurring on the endpoints, that quite frankly, it's not going to leave enough digital footprint on the network. But if we were looking on the endpoints themselves, all of a sudden there's like 20 different ways you could see it. And so endpoint monitoring solves huge visibility gaps. Encryption is not a problem on the endpoint, because at the end of the day, the data is decrypted. If you're trying to tie an attack through PowerShell to the process, to the parent process, to then the network call that was made, it's all there on the endpoint. So we have evidence, but the challenge then becomes, well, how do I tell on my endpoints to do the proper level of logging? How do I collect the massive amount of data? Like, network security monitoring is a lot of data, but when you go to the endpoint, talk about multiplying that by 10, 100, 1,000 times, depending on what you're logging. So we're introducing challenges and solving them at the same time. Now, I want to kind of put this in perspective. So take a look at this diagram here for a second. What this is a common attack methodology. Adversary somehow tricks a user into plugging in a USB drive. USB drive could have been something like a rubber ducky, a land turtle, a Raspberry Pi device, an Arduino, something that it then ensues like a PowerShell command and control. PowerShell command and control can evade traditional antivirus. Even if you have whitelisting, it still can work. So now all of a sudden you have PowerShell command and control. You've got persistence so that if the box reboots, it's still going to be there when it comes back up. From there, the adversary has control of the box. So they steal credentials, they pivot, they steal credentials, they pivot, and they just rinse and repeat. Exploits still happen today, but if you look at like Mandiant M-Trends, Verizon data breach reports, or any online research papers, you'll see a common theme of live off the land attacks, credential theft, credential reuse. From there, they might add a local account for easy backdoor access if they even need it, because they have credentials stolen anyway. And then let's just assume at the end of the day, the attacker stole whatever they wanted, cleared all the logs, and then left. I love this diagram because it shows 1,000,001 different ways you could have catched that scenario. And really, if you caught it in steps 1 through 4, you could have won, because until the attacker stole the data, they didn't win. But the problem is, if you look, you've got multiple ways of catching each step. You'd have to know about each of the steps. You'd have to have these logs enabled, and sure, they're native to Windows, but what if the problem is you're trying to do the same thing on Linux? What if you're trying to do the same thing on Unix or Mac? There are built-in logs, but now you have to have someone with the expertise. They need to be maintained on staff, like no constant rotating of employees where they quit and you rehire them. You have to have the proper logging. It changes over time. Like Windows 10 is not Windows 10. You've got the fall creators update, the anniversary updates. The mechanisms for logs change on those. So now you're in this labor-sucking process where you have to keep updating yourself. You have to know what to look for. And then even quite frankly, there's still things that weren't identified in that previous slide that you would have no visibility in because you're using the built-in logging. Lots of visibility, but we're technically saying, and I'm saying, we still need more visibility. So what we really are trying to find is a solution that will let us consistently have the log and visibility we need across systems, across operating systems, that the expertise for knowing what to log, what to report on, is more controlled by a group of security experts. And that's kind of where endpoint monitoring has been constantly getting better and better. And that's where we started to see the evolution and introduction of endpoint protection platforms and endpoint detection response programs. So let's just kind of consider a scenario here for a second. Let's say in the morning I open my email and I find that someone sent me a PDF attachment. I open the attachment just because that's how I roll. And if you send me something, I've got to click the link. I've got to open it. And then Adobe Reader crashes. In this, Adobe Reader is going to crash, and it's going to generate a log that it crashed. I then open the PDF again, because if at first you don't succeed, try again, and it doesn't crash this time. Now, I'm going to guess most of you on the call are security experts, and so you would be immediately red flagging this. PDF Reader crashed. It could have been a client-side attack over a phishing attachment that it crashed because it tried to run a PDF exploit. It didn't work, or it did work, and they have command and control, and then the second time nothing happened. Or maybe it worked the second time, but not the first time. Now, that's because we're all paranoid at this point, and it's a security webinar. But what if I just open a PDF and it crashed because sometimes things crash? Now, let's be clear, which one happens more often? Do users open PDFs, or maybe they get impatient because it's like a 20 meg PDF? They click on the title bar, it goes white and says not responding, so they kill it. That logs itself as a crash. Like, there are operational reasons that this same behavior could exhibit, and that's actually a normal event, not something bad. But if you're looking for malice, you're collecting logs like Adobe Acrobat Reader 32 has crashed, here's the time, here's some false information, and you're investigating that. That is part of endpoint monitoring. The problem is, okay, Adobe Reader crashed. That's great. I'm glad you're looking for client-side phishing, but is this technically something bad? Is this something you want to investigate every time? This is effectively a single entry in a sea of data, and it lacks context. And to me, this kind of personifies the epic fail behind endpoint monitoring. Like, I love SIEMs, I love endpoint protection platforms, I love EDR, but all of them can suffer from the same issue, especially monitoring solutions, in that we single-handedly point and we place our bet on one log, but we really don't have the context we need to make a decision. And to me, this is by analogy, think of this as you're in Vegas and you're playing roulette, and you're putting all your chips on one number. It doesn't work because statistically you don't have good odds. we need to level up. So EDR, Endpoint Detect Response, is supposed to be the endpoint monitoring solution to solve all of our endpoint monitoring needs. It's not based on just looking at Windows logs. It's based on looking at processes, at memory, at file monitor information, at all sorts of things. And the goal is I can deploy an agent, an EDR agent, on multiple assets. They could potentially be different operating systems. And it's going to automatically crawl through the massive sea of data and try to generate what I refer to as anomalies. Hey, I saw that Adobe Acrobat crashed, and by the way, something was interacting with depth or ASLR, or it looks like this is a potential heap spray attack, or like it's going farther down the rabbit hole than just what we have built in. This is going to generate an anomaly. And if you've ever heard me give other webcasts, I often will say anomalies are not alerts, alerts are not anomalies, but a high enough anomaly can turn into alert. That's confusing. But the concept here is central management, central visibility, and it's looking into a greater level of detail to generate these anomalies. So it's a pure gap visibility detection component. The problem with this is EDR in its current state. So today, 2019, I go out, I purchase an EDR solution. I slap it into my environment, I deploy some agents, I smile because I see so much log data that I just, oh man, that makes me happy. You know, I'm the kind of person that more data is, well, you give me more data and all I'm going to turn around and ask for is more data. But I'm getting anomalies. It says that these things are potentially weird. I investigate them. I have central visibility, and it should be like a high five at the office desk. We're all going to go party because it's just amazingly awesome. And on day 1, day 7, maybe even day 30, it is. But what starts to happen is you get more and more anomalies, you have more and more visibility, and you still don't end up having the context you need because there's so many anomalies being generated because there are natural deviations from norm that you have to start investigating all these. Now, I'm a big fan of having an alert queue, like case management, incident management, where I investigate all alerts. But an anomaly is not an alert, and an alert is not an anomaly. An alert is, hey, this probably should not have happened or is unauthorized. You need to look into this. An anomaly, especially a single data point anomaly, is saying, hey, I saw your endpoints do something that's not normal. You should look into it. But if you looked into every single thing that your endpoints were doing that weren't normal, you would never complete. And so that smile you had on day 1, the smile you had on day 7, by day 30, that's turning into a frown. Like, I've seen many EDR solutions that get deployed, and then the problem is what you bought to solve a problem introduced a worse one. Like, you spent a lot of money to get visibility, and now you're drowning in a sea of anomalies, and you cannot potentially keep up with it. Like, it's generating so much stuff, you're not getting through it. And so then what you start doing is you start to arbitrarily pick thresholds. Like, this has a high enough anomaly score, I'll treat it like an alert. But now you're not using the full visibility. And yes, you have so much data that I can start with the anomaly and pivot to surrounding data. And you do have the logs to do that. But that takes time, and it's a rinse and repeat, rinse and repeat. So to get away from this, what we're starting to see is the natural evolution to, I think, what should have happened in the beginning. This is the concept that we're referring to as Active EDR. If you still deploy an agent, you still have a massive amount of endpoint logs, but the difference here is when it's looking for anomalies, it's not looking at just a single condition. It's effectively performing an analyst action and telling a complete story. So think about this like this for a second. Let's say Adobe Reader crashes. Okay, that's great. What happened around that? Were there network connections? Were there new processes being spawned off? Were there service creation events? Was there recently a USB drive inserted? Was there, and it starts to go through a series of multiple things, and the vendors now are taking security expertise, and rather than just deviating with a single anomaly, they're gathering surrounding context because that rinse and repeat nightmare is basically taken care of with the implementation of Active EDR. It's effectively trying to do the analyst. So now, yes, you still technically have an anomaly, but it's a context-driven, story-told anomaly that has been pre-investigated and pre-analyzed. In fact, because of that, it might actually go immediately to it was an anomaly until we did all this other work and now it's not, or it was an anomaly and hey, by the way, this one's probably pretty serious, get. So Active EDR is that mapping of an analyst mindset directly to the platform as if the old school anomalies from EDR are actually being investigated. At a minimum, at a bare minimum, this makes EDR actually palatable and consumable. You're still getting a whole bunch of data. That's a good thing, it's a bad thing. The difference is when you get something that hits a queue or anomaly or alert, the vendor is putting their expertise in and they're pre-investigating. So when you click on it, that story is told right there. And you might have gone from something taking, say, an hour per investigation to 5, 10 minutes because all those checks you've done. If you heard of things like SOAR, Security Orchestration Automation Response, well, that's because SIM was flawed, and so we had to append SOAR to it. Well, in this case, EDR is flawed, and it's kind of the similar aspect for EDR. So you're baking this in. So again, go back to that PDF for a second. If you had EDR and that PDF crash occurred and it was relaunched, you would probably get an anomaly. You might even get an anomaly and you have another one for a weird network connection spawn. But if I had an active EDR in place, the difference is no matter what anomaly hits your desk, it has the completed investigation in it. So you click on it, you look at it, you visually see, you trace back what's happening, and you're either done because it's a false positive, or it's time to kick off actual incident handling because you already have enough information to say something bad occurred. So that is the beauty, again, of Active EDR. It's baking in the analyst activities into this platform. So, okay, this would be kind of the completed story going on here. I open Outlook. From there, I open the attachment. I get Adobe Reader. If this was just a bug, maybe it tried to make a web call that failed, then no actions necessary, and hopefully in an Active EDR platform, it's not even going to generate this as an anomaly. Or if it does, when you click on it, it's such a low score and it gives you all the reasoning onto why it's a low score. But on the counterpoint, if this is a hack, like I pen testing you, I sent you an evil PDF, client exploit ensues, you get a command and control reaching out, maybe it's downloading stage 2 download files, all of this is taking place. And again, if I see that anomaly, in this case, it's something that's going to promote itself to an alert, I have all the data I need on it because it's going to visually show you this. It's going to show you, hey, looks like this box is infected. It's connecting outbound to this asset. It came from a PDF. That PDF was used to launch this exploit. And that PDF came from, well, did it come from Internet Explorer? Did it come from Outlook? Like, where did this come from? You're not doing the investigation. It's doing it for you. This to me is, again, you're paying for something here that is automating this task now to solve the problems that we originally started off for. You're not introducing new ones. You're actually getting the visibility. And then because it's so much visibility, you now need it to also do the investigation and tie and correlate and link this all together. That's what's getting fixed from the original EDR design and flaw. So, biggest thing. To me, if you're going to buy EDR today, you have better be careful that you're not generating more data, more anomalies than you keep up with. By far, that is the number one reason I see EDR solutions fail. But the cool thing here is a lot of organizations will say, well, our EDR didn't fail. We're just not technically keeping up and looking at all the anomalies. So it's like it's a half-truth. No, we invested that money and it's not a total failure because we still have great visibility. But that's probably not the original justifications behind the purchase. So what happens, again, is you just get so much data that you can't keep up with it. Now, what I would recommend you do, regardless of if you have EDR or not today, start to map out how long it would take you to investigate things. If you have EDR, just time yourself on how long it takes you to go through all the anomalies and data it generates. If you have SIM, if you have intrusion detection systems, if you have a next-gen firewall and you're doing IPS and IDS style signatures, I don't care. Figure out how long it takes you to look into things. Then, when you start to evaluate and mature your organization, look at not EDR, but the active EDR solutions, the ones that are going to holistically tell you that story. And again, run through things, measure how much time it's going to take. That is the justification for gaining tremendous amounts of visibility on your endpoints, but not drowning in it. That is the whole point. Again, fix the visibility without flooding yourself. That to me is the biggest advantage of an active EDR. So, okay, passive EDR fills the hole in visibility. We don't have to have massive Windows, Linux, Mac expertise that tells us what to log, how to collect it, some type of platform to essentially bring it in. We don't have to keep changing and hardening and updating. and we're getting all the data. The problem with passive, again, though, is, well, it's passive. You're doing the work. You're getting your feet up. You're going to the keyboard mouse. You're driving. It's not active because it's just effectively data. You're the one that's actually doing the footwork. Active EDR is active because it's an active participant in the data. You're getting all that same data. You're getting anomalies, but they're better. They're driven. They can be used for prevention techniques because it has the full storyline to actually make results happen. It's doing it. You still can tune and control the settings. The difference is you're not doing as much work because it is right there alongside you in the driver's seat. So active EDR is a natural evolution in where EDR solutions need to be because they're active participants. So just kind of hashing this one last time. So passive EDR, that's going to give us all the detection capabilities. But it's point in time, it's that looking up from the bottom of the well and only seeing part of the picture. You're then going to have to pivot and look at everything else. With active EDR, this is where we're getting real-time analytics. It's not just looking at that single piece of data, it's correlating with surrounding information. Because this is a natural progression, if you had better detection, better correlation, and it was trustworthy, well then now if it's on an endpoint, you can technically turn it into a preventive control because you can trust it to make the right decisions. If you were to say, I have an analyst and he looks at this, he or her looks at a given situation, and when these things happen, it's bad, and you plug that into an EDR solution, well, what you're saying is I justify the reason to block, prevent, clean up. With EDR, we didn't have that because we really didn't have good enough data. Anomalies were way too far from orders of truth. SIM with SOAR, same situation. Well, if we're programming all that logic in there and we trust it, we'll use the SOAR to automatically react. So active EDR is the evolution of combining these together because now I can see all this on the endpoint as it's occurring in real time and it's reacting. So active EDR versus passive EDR. So before I flip this over to Migo and let him talk, I just want to say real quick, if you don't have endpoint monitoring today, you've got to factor in, one, you're going to gain significant visibility with endpoints. Endpoint monitoring to network monitoring is a no contest. I didn't say network monitoring is worthless, by the way. I'm a huge fan of it, but they serve different purposes and different means. For the maximum visibility, you're going to have to do it on the endpoint. For cloud visibility, for things like infrastructure as a service, you're going to have endpoint monitoring. But if you're going to do that, remember, you're trying to solve a problem without introducing new ones. EDR is great. You'd be better for having it than not, but it's solving one problem and then creating another. So what I would recommend you do is try to figure out with what you're looking into is if you can gain the visibility, but also the logic behind it to contextualize the data, tell the story, introduce actual prevention controls that are based on solid reasoning and methodologies, and then consider the time savings you would get from that versus plain old EDR passive, or even endpoint protection platforms, which quite frankly don't have the monitoring capabilities you need to know what's going on anyway. So with that, I'm going to turn this over to Migo. And again, I appreciate being able to be on this, and I'll stick on for questions near the end.
Thank you so much, Justin. Great presentation. So hi, everyone. My name is Migo Kedem. I'm the Senior Director for Products and Marketing in SentinelOne. And in the upcoming 20 minutes, we'll cover those topics. We talk a little bit about the market. I'll give you an example of Active EDR in action, something we've seen in the wild. Then we will dive into how it really works. I mean, what's the technicalities behind this bold statement. And then I will share a little bit about SentinelOne if you haven't heard about us yet. So, sorry. So as Justin mentioned, I mean, we see more EDR being adopted by enterprises. This is a trend that has been happening for several years now. With that said, we still see a discussion about dwell time. So a dwell time would be something since the time of infection until somebody discover a malicious activity. This represents the dwell time. And of course, as customers or as people who protect the enterprise and the networks, we want dwell time to disappear, right? We don't want any malicious activity to run on our systems, on our networks. And it's still, people are talking about dwell time of 1 minute, sometimes 1 hour. In my mind, dwell time is something that needs to be simply real time. It needs to be 0. Whenever a malicious activity is happening, what we really want is to prevent it and eliminate the risk. It's also very hard to find people that can really do the work that Justin was talking about. It's also a tedious work, to come up and try to assemble a story of what really happened, because at the end of the day, what we really want to know is where something came from, what it was trying to do, what it was successfully doing, and to stop it before it does any malicious activity. This is really difficult task to perform, and like I heard, some organizations, they allow 4 minutes, 5 minutes, maybe 6 minutes per incident, try to investigate it, and it's really challenging to assemble all those pieces into a story that tells you everything that was happening. So when you try to investigate some of these anomalies, it's also, in many times, you all probably know that you try to investigate something and you discover it's simply nothing. So a lot of time is being wasted. And with all that being said, we still see, even though more EDR and more visibility is available now in the market, we still see almost on a weekly basis more and more organizations that are being hacked in so many different ways. So we're actually behind the attackers from that perspective. So Active EDR. To give you one example, and this is something that happened in the wild few times, what would you do if the FBI calls you and say, well, your information is now available on Pastebin? And this is not a theoretical example. I mean, you see stuff on Pastebin that is happening all the time. You see, for example, this breach, 770 million private information being dumped on Pastebin, a company from Brazil losing their data to, and again, it was available on Pastebin. And again, another example from Singapore healthcare, that again, the attackers tried to collect information and to store that on Pastebin. So what would you do with the Sentinel-1 solution from that perspective? It's pretty easy. So the Sentinel-1 solution is a single agent, meaning that you would deploy agent on your Mac, on your Linux, and on your Windows devices. This single agent is capable of both being AV replacement, capable of preventing everything that can be prevented, but it also gives you the option to get that visibility that we talked about. So in case somebody is telling you, okay, your information is on Pastebin, where can you start? So in the case of Sentinel-1, you just go and you just look for Pastebin and see what happens. Then pretty quickly after that, you will get all the post requests coming from your network into Pastebin. So in this case, there's only one device in the network, it called enterprise device, that was accessing Pastebin. So once we take a closer look on that attempt, what we see, we can get the storyline in a tree view. We can see that Microsoft Word was actually the one responsible to this particular operation. So when you another click away, and then you see Microsoft Word was spawning a PowerShell, then starting to do NSLOOKUP, trying to do a DNS hijacking. And from here, you can actually see on a timely manner exactly what was happening. You can understand exactly what device was involved with that. It's pretty easy. So unlike the passive EDR, where you would probably need to collect a lot of pieces together to try to assemble the story, here in like 2 or 3 clicks away, you can understand exactly what was the story behind this. And this is really the magic of Active EDR. But it's not only about visibility and after the effect. It's also what's unique about that is running on the device itself. And because it's run on the device itself, it is capable to make the decision in real time and also to prevent them from doing any malicious activity. Let's see a little bit how it works, and for that, here's a little bit of drawing of mine. Let me explain a little bit. Those are the 4 pillars one would expect the EDR today to provide to him. It needs to prevent thing, usually on write. It needs to detect, usually on execution. It also needs to be able to respond to malicious activity. And the 4th element would be the ability to hunt, like I just showed you. Like from a single URL, I was able to find out the entire story. So as in Sentinel-1, we of course check all these boxes. We prevent anything that can be prevented. This represents the agent side, and this represents the cloud. So you would get on a particular device, you know, a malicious files, you will get the benign files, maybe some suspicious files also. So we'll utilize cloud lookup if there is any, but what's interesting over there, we will use static AI in order to determine if something is malicious. Moving forward in time, we go to the detect, to the on execute thing, and this is really where the magic starts. So a lot of activities are happening on a device, and it's the secret here is really to maintain the story of each one of them, and this is really difficult to do. And before, Justin, you mentioned that this is what EDR was supposed to do to begin with. I think the problem was that this is very, from a technical perspective, this is a very challenging solution to do something on the agent without consuming resources and to be able to understand the stories as they're happening and to make decisions is not a simple task to code, right? So in this example, you can see few things that are happening, relationship between objects, but eventually in the beginning when story is really starting, you don't really know if it will become malicious. So it needs to still continue to run, and then when you find the malicious activity, this is where we marked it as malicious. So you can see this red circle here represents a malicious activity, and once this malicious activity happen, what we do, we actually label the entire execution flow as malicious. We use that using our technology called true context. But this context allows us to mitigate automatically on the device the entire execution. So in the example that Justin gave before, if, for example, something comes from Outlook and saves a PDF, and this PDF is essentially doing something malicious, we will know the exact flow, and we will kill anything that might cause harm as it happened without the need of any connectivity. This is really where the Active EDR really comes to play, because it's not only about contextualizing, it's also about translating that context into the ability to mitigate things as they're happening. It also means that you get less alerts. The reason you get less alerts is because once malicious activity is starting on a given device, it will be prevented or killed or quarantined, depend on the activity, immediately when it's being seen. So there will not be more activities happening after that point. So in reality, you get less alerts. You don't get alert for each single piece. You just get one alert for the entire context. You get the story, very similar to what I showed before. If you look for Pastebin, you get the story behind how come somebody communicated with Pastebin from my environment. So after this automated response is happening, of course, from a threat hunting perspective, I wouldn't say that threat hunting is not needed. I think this is something that is beneficial to any organization. What I would say that with Active EDR, you have less reasons to hunt, and when you hunt, you can focus on what matters. So you don't need really to assemble pieces into a coherent story. You really get all the context around activity so you can make decision. Like I'm showing here, you would get the entire story of each one. Maybe some of them are benign, others are malicious and probably was prevented as it was happening. But as a threat hunter, you don't need to assemble pieces anymore. You just need to do a query, you see exactly what it is, then you can make a decision. So a little bit about SentinelOne. We were founded in 2013. We have 330 employees. Half of them is actually R&D. We have in US, France, and Israel. Our headquarters is where I'm talking from now in Mountain View, California. I think it was almost 3 years ago when we were offering ransomware warranty. And later the market did follow, and now many vendors do offer that. Something interesting about that, how come we can offer that? I mean, some people would say, oh, it's not possible. And really the secret is about how Active EDR is working, because remember that Active EDR understand the full context. And when you understand the full context, you actually can also roll back a malicious activity. For example, a ransomware. So ransomware will start as a story, and then we start encrypting. It will be prevented, but let's say few files were encrypted. You can simply make one click on our console, and then you can roll back the entire malicious activity done by this ransomware to the original state. The user can continue work. There's no need to reimage the device or anything like that. It's even more than that. If he was working on something, maybe a Word document that was not encrypted, the rollback wouldn't touch that Word document. Because we know the entire context, we will touch just the thing that the ransomware was manipulating. So it's really like a magic when you see that. There's a ransomware. We have a lot of those examples on our YouTube channel. There's a ransomware. We allow it to run on the detect mode. Usually for demo we do that. On a real life scenario, we most of our customers, actually almost all of them, are running on protect mode. So once we run on detect mode, we allow the ransomware to run, and then we can roll it back completely to its original state, including background, splash screen, and everything. If there's any registry or any activity like that, startup thing, we also revert that to a normal state. What really pioneered is what we call the behavioral AI, and this is kind of a different name to our Active EDR. It's really a model where we maintain the stories. Because we maintain this model, and all the time we know exactly if something, who is the father of it. And for example, if a malware trying to, I don't know, use WMI or MSHTA to do something, we know the real owner of each activity. So even if somebody is using system processes in order to do something, we really know who is the originator, which really helps when we come to mitigate that. Our funding, almost 110 million by Redpoint and Third Point Venture. We were 3 times visionary by Gartner, twice recommended by NSS Labs. And of course, I recommend all of you just go to our website. You can also reach out to me, Migo at SentinelOne. Try it out, see for yourself, because that's the best proof for that.
Well, thank you very much, Migo and Justin, for those great presentations. We do have a few questions ready for a Q&A session. Let's see here. Our first question. In regards to SentinelOne's rollback feature, how much time after the infection can the agent roll back?
Thank you, Debbie. It's a very good question. So the way we implemented our rollback feature is we utilize VSS on Windows. So we actually keep the journaling of everything. We have additional code, of course, that take care on additional things like registry, which is only partial. But it really depends on how much encryption was happening in case of a ransomware. I've seen cases where even a week after the infection, the agent was able to roll back. But at the end of the day, it's really a question of how much space one will allocate to the VSS shadow copy. And of course, in real life scenario, ransomware is something that is pretty obvious. It's actually very difficult to ignore. You get a splash screen, your files are being encrypted, so that's pretty visual. And usually you don't need to go back in time and to do a rollback. But I've seen even more than a week that the agent is capable of rolling back on a normal environment.
Very good, thank you. On the size, how big is a Sentinel agent, and how much bandwidth and processing power does it consume?
So in order to mitigate that concern, because when people understand how we work, it's a question that comes. We collaborated with Passmark, and they created a test for us, comparing us with other endpoint security solutions. As you can see, we were starting in 2003. It took a while to make that very efficient and not to consume resources, but now it's very stable. We are running now successfully on 3 out of the Fortune 10. So those are like huge customers, you know, they would not tolerate any resource consumption. And again, there is the Passmark evaluation in order to prove that. So we don't do any scanning or anything like that. So you don't see spikes of CPU or anything like that. You don't need to do recurring scans or anything of that nature. We don't require update because it works using AI. So it's pretty light on the agent. Just to conclude my answer, it's pretty light on the agent. And of course, I do recommend try it for yourself.
Great. I have a question on, can Active EDR do automated threat analysis and remediation tasks to reduce threat hunting workloads?
It does. So the way it does that, it does everything on the agent as it happens. And in a typical policy, it will also prevent the malicious activity. And then immediately from the console, you will get all the information. And all the information that you get in the console would be a lot of attribution. Was it ever seen before? What was the reason for the detection? We also have MITRE mapping to everything that we detect. So if something is being detected, you can see exactly by the MITRE TTPs exactly which elements were discovered. So it's really the next step of threat hunting in my eyes. It's not exactly the work that a threat hunter or analyst was doing before, meaning assembling pieces of information, trying to put them in context. It's more looking at context and reviewing other context and deciding what to do with them. So it definitely reduced the workload of threat analysts. With that said, we have, as I mentioned, those customers, they have a lot of people on the SOC which their job is to analyze and to look into, and they still select SentinelOne because it simply makes their work more efficient. It doesn't make it redundant, but it does make it more efficient.
Okay, great. Here's a question. Can SentinelOne run on detect-only mode?
Yes, of course. So the policy in SentinelOne is pretty simple. We have like 3 modes. We differentiate between a threat and suspicious activity. By default, we prevent threats, which is more high confidence, and suspicious activity, we just detect them and then you can go and review them. Most of our customers are running actually on protect mode, which means both suspicious activity and threats would be mitigated as they're seen. And also we allow a full detect mode, which means that nothing will be prevented. SentinelOne will run on the background. We also support, if you don't want the UI, you can dismiss the UI also, of course, from the console. And then if something, for example, would come like a ransomware, you still be able to go to click the rollback from the console and to get everything reverted back to normal. So the answer is yes, SentinelOne can run on detect mode. I'm not sure I would recommend that in the long run, but that's, of course, an option that we provide.
Okay, great. And we do have one more. How well does SentinelOne work with automated playbooks, runbooks, and SOAR tools?
Great question. So it's actually before my time. So somebody very clever in our R&D decided that everything in SentinelOne would be API. So whatever capability there is with SentinelOne, it exists on the API. Actually, our management console itself works with that API, so it's even more rich than what you get from the UI itself. What it means from connecting to SOAR and to orchestration is that you can do so many things with SentinelOne. I've went to customer sites and I've seen some amazing integrations they build. There's so much. I think there are like 300 pages within the console of the API guide. You can do almost everything with SentinelOne. And also remember that because we detect in a different way that is not based on reputation or anything like that, it's also kind of allowing other products, enriching other products from that perspective. The classic scenario would be that SentinelOne discovered something that was never seen before, and all the IOCs, maybe the IPs, maybe the hash itself of the files that are involved, maybe registry keys, can be then fed into SOAR and orchestration in order to look for additional evidence or to understand better how it looks from a networking perspective or from other security solution that exists in the network.
Okie doke. And we do have one last question. What operating systems are supported?
So we support, of course, Windows, we support Mac and also Linux. I think we have among the next generation players the widest range of Linux flavors that are being provided. Red Hat is one of our customers. Of course, we're very happy with that and work with them very closely. So we're covering the entire landscape of endpoint devices. As of today, we don't support mobile. We do integrate with Lookout in order to deliver that to our customers, but we are covering like more the traditional endpoints.
Great. Well, thank you so much, Justin and Migo, for your great presentations. And to our audience, we greatly appreciate your listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. A quick note, you can find your CEUs for all completed webcasts by logging into your SANS portal account. Navigate to your account dashboard, then click on My Webcasts, and then you can download your CEU as seen on the right-hand side of the web page. And until next time, take care, and we hope to have you back again for the next SANS webcast.